Dr. Kelly, Business Edge Limited. 12 minutes, please.
Okay. Good afternoon. Sorry, just get used to how this thing works. My name's Kelvin Kelly. The name is coincidental, but I'm the training director for Business Edge Limited. I was asked here to talk about the F-gas training, which has been mentioned many times, and obviously then training on alternative refrigerants, or what I called low GWP refrigerants, but I'm changing that now because it depends on what numbers you're using. I won't bore you with who we are, what we do. We're just one of the leading training companies in the UK. I've also been working quite a lot with Centro Studi in Italy on F-gas implementation. But we'll move on, as time is always short. Like I say, we're going to talk about training on low GWP refrigerants, but it's not just those, it's also the other refrigerants we've been dealing with over the last couple of decades. Again, a lot of this information has already been given to you about the progress or the movement from one refrigerant to another, so I don't think I need to reiterate what we have already been told. But when we go to what's occurred under EC Regulation 842, this information on the screen is relative to what I've been doing in the UK. Well, not just me, but other training providers as well. Allegedly, we've certified over 20,000 engineers in the UK, which is around about 85% of the total. The total seems to be a little bit fluid. Allegedly, everybody was meant to be certified by 2011. We're now in 2013. We did certification courses last week. We're doing certification courses next week, and so on. These are not people that are new to our industry. These are people that have been or are working in our industry and continue to work. So maybe with regard to policing of the regulations, there's some scope for improvement. But anyway, at least these people are still coming through. There are still countless others that continue to work and do the service maintenance installation of refrigeration, air conditioning and heat pump systems who have no desire to get certified. And I don't know how we're going to get hold of those people with things as they currently stand. But we're, as Business Edge, we see that obviously the bulk of what we need to do with regard to current F-gas regulations, we've achieved a large amount of that, and we need to move on to the alternatives. There's nothing new. We've been, as an organization, running safe handling, if you want to call it that, training courses and assessment courses for various low GWP refrigerants for many years. But in the UK now we have some changes. Traditionally, the old voluntary refrigerant safe handling schemes used to cover refrigerants such as hydrocarbons. This is nothing new. I first started certifying persons for handling of hydrocarbon refrigerants in 1995. So we've been doing it for some time. The certificating bodies changed the way they viewed things and have now progressed or moved on and now have a modular approach, which is very similar to what Graham was talking about earlier. There's no requirement for retraining or starting from scratch. If an engineer has proven competency and whether or not training is required is another matter with regard to the F-gas regulations, but if he's proven competency up to now, there's no real need for him to start again and go all the way through it. All we need is to prove that that engineer is capable of handling the particular refrigerants. So there are modules in place which we are already training and teaching and certifying people depending upon what they require in CO2 design and maintenance and servicing, hydrocarbon design systems service and maintenance, and also ammonia. Now, with regard to the HFOs, the certificating bodies are combining those in the hydrocarbon scope, in the UK at least, because they say if it's mildly flammable or highly flammable, the fact is it's flammable, and the way you handle them and treat them is pretty much the same. Hello, I do apologise. My one looked a bit different to this, but it's probably because I had to email the presentation. But again, we've gone through what different refrigerants are, and sorry, I will go back one. We also talk about safe handling of refrigerants for the automotive side of things, which I'll talk about in a moment. And the one thing I wanted to make people aware of, we're finding the biggest stumbling block with HFOs, because we have clients who are working on automotive systems already charged with HFOs. They've already come in to be serviced and maintained, and it's the difficulty that the mechanics are having of obtaining the HFOs for rework and service. Not that it's not possible to get hold of, but it's financially difficult to get hold of. But I'll reiterate that in a moment. Obviously, with regard to what we're doing, obviously training on CO2, we've got the pressures problems. With ammonia, we have toxicity problems. Hydrocarbons, it's the flammability issue. I didn't have time to go through everything, so I chose hydrocarbons as a reasonable example of what's required. Also, just a matter on safety, it's been mentioned a few times. People are saying that CFCs, HCFCs, HFCs are safe. I don't believe they're safe. You know, we have lots of incidents and accidents where people are hurt, where systems fail, catastrophic problems with systems which aren't running on ammonia or CO2 or hydrocarbon systems. A lot of it is just down to competency. If you're competent, you usually work safely. Well, it's part of the definition of competency, is that you have an ability to understand your own limitations. So, obviously, with hydrocarbons, there is this increased problem with the flammability side of things. The awarding bodies and the schemes that are already in place in the UK, which could easily be rolled out across Europe, cover certain requirements for practical assessments. So persons have to be able to prove that they can competently carry out various activities. The biggest one being rework on these systems using some form of heat, such as debrazing or brazing in components. Now, obviously, if you're working or servicing a system that's previously been charged with a flammable refrigerant, there is a problem or potential problem of then when you approach it with an oxyacetylene torch or something of that kind, that you could get to a flammability limit and cause a potential fire. It's nothing difficult, it's not too hard to achieve. There are processes in place, there are practices in place that people have been carrying out for many years. You recover the hydrocarbons from the system. You have to ensure that you agitate the oil quite often from in the compressor to free up the hydrocarbons from the oils. We do a partial evacuation, then in pressurization with inert gas, again to help this agitation. And then the evacuation side of things is done with a remote discharge and so on. But it's all capable and being done, and no real incidents or accidents. Like I say, for the last sort of 15 years or so, we've been doing this, and no serious problems, as long as the people know what they're doing. The biggest risk we find for engineers is the fact that they're not comfortable with some of these refrigerants, and they hear problems that may be exaggerated, and therefore they don't come to the system feeling confident. And that lack of confidence can cause problems. I also noted Graham's comment about the types of recovery units that are available for safe handling or removing of hydrocarbon refrigerants. We also have only found one recovery unit which is capable of doing it at the moment. And it is heavy and it is bulky and it's no, I shouldn't say any more. But the thing is, the bulk of the hydrocarbon systems that we're coming across have very low refrigerant charge. And under legislation such as the WEEE directive, as long as it's safe to do so, a lot of these systems are just vented to atmosphere. So there hasn't been the requirement for the equipment manufacturers to actually invest in re-engineering of the recovery units to allow them to recover hydrocarbons. As they become more in the mainstream, I imagine that will not be the case, and it shouldn't be too difficult for them to adapt existing recovery units to suit. We don't think. Also, obviously, with the recovery side of things, the problem we have in the UK, at least, I can't comment for the rest of Europe, is even if an engineer has a suitable recovery unit, does the recovery process, it's very difficult to get recovery cylinders which allegedly can cope with hydrocarbon refrigerants, even though it's just a cylinder, and then it's very difficult to then reprocess that refrigerant. The major distributor of hydrocarbons in the UK, when we contacted them to actually achieve this process, it took us about 5 different telephone conversations with 4 different departments before we could speak to somebody who knew what we were talking about, which was a bit of a concern. There's also theoretical aspects as well that the engineers have to cover, but I won't bore you with that, but they have to prove competencies on their ability to actually calculate permissible weight of charge for different fluids as well as physically being able to handle them. The other side of it, which I've already mentioned, that we have concerns with, we do training on low GWP hydrocarbons, HFOs, should we say, for the automotive industry. And we're doing a whole range of training courses for that area. The concerns we have with those, obviously, I won't go into the political side of things of which refrigerant is the best for automotive systems. We already have HFOs in certain motor vehicles. We have people allegedly working on them. The difficulty is the equipment they're using, the systems aren't very well labeled, and the type of engineer that works on these systems may not be particularly well trained. There are systems such as the one, if I go back a couple, like this one, I'm not saying this particular make, but this was just an illustration. But this type of equipment is used quite commonly in these garages. They're hybrid systems. Some of them are called hybrid systems. They can recover both R134A and HFO, but not at the same time or not simultaneously. There has to be adaptations done. If they're not aware of that, they can easily cross-contaminate HFOs into R134A systems, which then can be continued down the chain to various other motor vehicles. I'm running out of time, so just one last thing. There's a lot of scaremongering about some of these refrigerants in comparison to other problems. This particular slide was given to me because it was supposed to illustrate an issue with a hydrocarbon system. This is from a local fire authority. This was an acetylene cylinder that went up where somebody was actually doing some rework on a frozen food area. So this was the acetylene cylinder that exploded that causes this problem, but it was reported as a hydrocarbon issue. So just thought I would put that in place. So thank you, sir.
Thank you very much. Ci sono interventi? Prego.
Hai alzato la mano? Hai alzato la mano, no? Scusi, sorry. No?
If we look on the HFOs, because of the flammability, they have different connections for mobile air conditioning as far as I know. And to my knowledge, there has been something like 5,000 to 6,000 charging and recovery systems being installed already end of 2010 in a lot of workshops. So at least some people might have been trained in that.
True. This is true. The connections for HFOs have been altered compared to 134A, but when you buy equipment, certain pieces of recovery equipment, they come with adapters for both 134A and HFOs, and you just swap over on the hose connections. And some of the OEMs, the labeling on the vehicle, it's not very clear whether or not it's an HFO or 134A. Some of the labels are only to be found on the compressor, not on the data plate in the engine housing, which is where we've had some issues before.
Thank you.
Good.
Thank you very much.